welcome back, and we're going to discuss derivatives today. So I'm going to first pull up a derivative rule table, and I'm going to take you through a couple of these, really through the next few videos. We're just going to go through all of these and introduce the derivative rules. Now, before we use the definition of derivatives, and we went through this long process of finding a simple derivative, but these rules are general rules to find the derivative of any equation without having to do any of that messy work, because it's all been derived for you. But we just need to know how to use these. So to start off, I'm going to introduce the first rule, and that is the derivative of a number. So let's say we want to find the derivative of 5. This is just equal to 0. And this makes sense because if you have a graph where the equation is y equals 5, or y equals any number, just say like y equals 1, the line's going to look like that. The slope of this line is 0 at every point, so the derivative is 0. And this is true for any number. It doesn't have to be a whole number. It could be a fraction, derivative of 1/2. It could be an irrational number, derivative of pi. It could be a negative number. Negative pi is also 0. And so on. So that's the first rule. The derivative of a constant is always 0. The next rule, the derivative of x is equal to 1. And similarly, if you had the derivative of 2x, this is just equal to 2. It's equal to whatever is out front of the variable. And you could do this with any variable. We called it x, but we could just as well call it z. Derivative with respect to z of 2z is 2. And in a second, we'll understand why this is the case, why you can just take the number off of the actual variable and make that the derivative, or what the derivative is equal to. There's reasoning behind that, and we'll get into that here in a second. Alright, and now let's consider derivatives of something raised to a power. So the derivative of x squared. So I'm going to do a couple of these until you get the hang of what the rule actually is. It's actually a pretty simple rule. So I'm going to do a couple of these, see if you can guess what the rule is, and at the end, after 3 or so of them, I'll tell you what it is. The derivative of x squared is just 2x. The derivative of x cubed is 3 times x squared. The derivative of x to the 4th is 4x cubed. Now by now, I'm hoping you'll see at least some sort of pattern here. If it's not obvious at first, you can at least see that as the power increases, the number out front is also increasing. So an easy way to remember this rule is no matter what you have in the power, so we'll do x to the 10, for example. To find the derivative, you take this 10, you bring it out front, and then you subtract 1 from the top. So in this case, the derivative of x to the 10th would be 10 times x to the 9th. So again, we brought the 10 out to the front, and then subtracted 1 from the original exponent. And this rule is more generally written as the derivative of, or excuse me, not u, derivative of x to the n is n x to the n minus 1. So this is the derivative rule. And this is the case even if you have a constant out here to start with. So in this case, if you had a constant, you would just multiply it at the end. So another example, the derivative of 10 times x to the 5th is going to be, so we'll bring the 5 down, and by bring it down, I mean multiply it with whatever is here. This is going to be 50 x to the 4th. So we brought the 5 down, and we subtracted 1. This is the case for exponents with negative values as well. So the derivative of 3x to the negative 2 is going to follow the same rule. So we bring the negative 2 down, multiply it out front, so this is negative 6. And we subtract 1, and since this is negative, subtracting 1 turns it into a negative 3. And this is why the derivative of x is 1, or the derivative of 2x is 2. That's because if we follow the same rule, 2x, this x has an exponent of 1. So by taking this derivative and we bring the 1 down, 2 times 1 is still 2. We get 2x to the 0, but anything raised to the 0 power is 1. So that goes away, and we're just left with 2. So that's why that second rule that we went through actually works. Alright, we'll do one more example. Let's do pi times x to the, we'll say 1/2. No, sorry, we'll say 3/2. Oops. Pi times x to the 3/2. Now this looks tricky at first because there's a fraction in the exponent. But we do the exact same thing we've been doing this whole time. We're going to bring the 3/2 down. So we're going to get 3/2 times pi x and then subtract 1. So 3/2 minus 1 is 1/2. This works with fractions as well. Alright, and that is this, let's see, where was the rule for exponents? That was this power rule here that we just went through. Alright, now derivatives have a couple different properties. They are commutative, so if you have the derivative of two things added together, so for example, let's say we're taking the derivative of x squared, and so x squared plus x cubed, the derivative of this entire thing. We can distribute the derivative to each piece, and this is the same thing as the derivative of x squared plus the derivative of x cubed. And vice versa, we could go back or forth, however we want to do it. Now following the power rule, this piece is going to become 2x, and this piece is going to become 3x squared. So that's the answer. Alright, so we went through the power rule, we went through the sum, we went through the constant. Same thing with subtraction. Oops. So this would be just as valid if this was a minus, which makes sense. Alright, and then you can also bring constants out of derivatives. So we did this a little bit earlier, but if you have the derivative of 5x to the, just for fun, just do 100. This is the same thing as 5 times the derivative of x to the 100. So if it's a whole, or not just a whole number, if it's some constant multiplied in front of the function, and this constant doesn't depend on x, then you can bring it outside of the derivative. So in this case, to finish this derivative, we would get 5 times 100x to the 99, which would be 500x to the 99. Alright. And so this whole time we have been doing something with respect to x or something with respect to a single variable, or a specific defined variable. But really when you use derivatives, you want to get in the habit of including another piece on it. So going back to our power rule, derivative of x squared, we said this is 2x, but it's really 2x times dx. That's really the answer. And as you do more and more derivatives, I would highly recommend you get into the habit of writing this dx. Now before we said the derivative of x is 1, so in reality this is almost always going to go away. So the answer is still going to be 2x, but you want to keep that dx there for a later rule called the chain rule. So just for now, accept it and just get used to writing dx or d whatever variable it is that you're using. So if we switch what we call the variable, so d over, we'll say dq or something, for example, of q to the 5/4. This is 5/4 times q to the 1/4 dq, or d over du equals u to the, or excuse me, du of u to the third equals 3u squared du. I'm telling you, this du will become important in a little bit. And I'm going to show you two more rules. We're just going to finish up this general formula of derivatives. I know I'm moving kind of fast through this, but we have two more rules to go through. So we went through the power rule, we went through the derivatives of constants, the derivatives of a single variable, but now we're going to look at the derivative rule of things multiplied together. So the derivative with respect to x of x squared times, we'll say, x minus 2. There's an easier way to do this, but just for the sake of describing the product rule for derivatives, we're going to go through the actual product rule. So the derivative of two things multiplied together is going to be the first times the derivative of the second plus the second times the derivative of the first. A lot of times this is written in terms of u and v. I don't know why they chose two letters that are very similar, but u times v. And the answer is written as u dv plus v du. So in our case up here, we said u is x squared, and actually I'm going to use colors for this. Let me see if I remember how to do colors. Okay, so we said the derivative of u times v equals u times dv plus that should be a u plus du times not dv times v. And in our case up here, we have v equals x minus 2, and we have u equals x squared. Alright, so let's plug in our u's and our v's and our du's and our dv's. So first thing is u. So u is x squared. So this is going to equal x squared times now dv. So again, dv means derivative. So the derivative of x minus 2 is just going to be 1. Because of the commutative property, taking the derivative of x minus 2, you can split it up and take the derivative of x minus the derivative of 2. And derivative of x is 1, derivative of 2 is 0. So this is just equal to 1. So we have x squared times 1 plus, now going back up, so our derivative of u, so we said this was u here, x squared, so the derivative of u is 2x times, and our v is x minus 2. Now we can simplify this a little bit. So this is going to equal x squared plus, we'll distribute this 2x, plus 2x squared minus 4x. And this is going to equal 3x squared minus 4x. And that is the answer. So that is the derivative of x squared times x minus 2. Alright, I think I'm going to stop the video there. In the next video, I'll do a couple more examples of this, and then we'll go over the division rule, or the quotient rule.